talking about parent functions, or basically introduction to parent functions in grade 11. So what exactly are parent functions? Parent functions can be said as the core function types without manipulation, right? They're also known as the base function, right? That's exactly what a parent function is. This is the original function without any transformations applied to it. So that's what a parent function is. Now we're going to move on to the examples / types of parent functions. So we have the linear function here, right? Probably seen this one before, the linear function. It's basically a straight line, right? So, and then after that we have the quadratic function. Probably used to it. It's a parabola, right? It looks like something like that. Oops. A parabola can look something like this, right? Remember? It's a parabola. The linear function is usually a straight line, right? It can be like that, right? I'll go into more depth into the graphing later on, but that's what the linear one could look like. Absolute value function, also known as mod x, looks something like this, right? It can be something like this, it's like that, V shape. And then we've got the square root function, right? We can do something like that. Boom. And then we've got the reciprocal function right here, which is interesting because it's like it has an asymptote, so it goes on both sides like this, and then it goes like this. Now these are all just rough drawings of what they will look like, but let's actually see what they look like in an actual graph. So I've got all my functions listed out here. Remember, f of x can be, can be just set as y, right? So f of x equal to x is basically y is equal to x, right? It's just to say it's a function, right? With y. But here I just put y, just so it's easier to understand. So let's start y is equal to x. Let's click on that. We can see the straight line that crosses the origin point. It cuts through. Pretty simple, right? That's a linear function, or the base linear function. And here we've got the base quadratic function, which looks something like this, right? Y is equal to x squared. And then actually we have a new one here, which is y is equal to square root of x, which looks something like this. It just keeps going up and up and up. Something I like to tell people is when you're graphing this, you always want to take numbers that you can, for the x value, that you can take the square root of, right? You could take 1, right? Because the square root of 1 is 1. You can take 0. You can take 9, which is 3, right? So those are some points you can use when you're making this graph. Next, let's look at the reciprocal function. This one's a little bit interesting, and sometimes it tends to confuse people. The reason for that is because it looks kind of wonky here. There's 2 graphs, right, coming out from each side, or from these 2 quadrants. So in this quadrant right here, we can see that the graph, it keeps going up, but it never touches this axis, right? It never touches it. It just keeps going up, right? And that is known as a vertical asymptote, right? This is a vertical asymptote of y can never ever be equal to 0. That's our vertical asymptote. And for this one, the x also has an asymptote. It has the horizontal asymptote, so it's HA, right? X can never be equal to 0 in this case, right? Keep looking, it'll never ever touch this. So those are asymptotes. And here's all there's an asymptote as well here. It has a horizontal asymptote here, and it has a vertical asymptote here as well. Never ever touch the value of 0. You probably go more into depth of asymptotes and things like that in grade 12, but for now, I guess this is all you need to know for the reciprocal function. Now let's look at the mod function, also known as the absolute value function, and you'll see why it's called that. So we can see when I plug in, let's say the number 6, right, or the number 2, I always get the same exact number back for the y value. So if my x value is 2, my y value is 2. If my x value is 6, my y value is 6. Same case goes for negative numbers. You get the positive numbers. See, this is why it's called the mod function. So it's the absolute value. Absolute value of negative 1 is 1, right? So if my x is negative 1, it's 1. If my x is negative 2, my y is 2. If my x is negative 3, my y is 3. See? That's why it forms this shape, right? Now I've got a parent function that, you know, may or may not, the teacher may or may not teach you this, but I'm going to cover it anyways. We have y is equal to the x to the power of 3, which is the cubic function, right? It looks somewhat like this, right? It's an interesting function. Yeah, you can see it crosses these two axes. And yeah, that's basically all that you have to know for this. So that's all. Thank you so much for listening, and yeah.